Hello and welcome back to Sting with Steve. Today we're going to cover a very important part in computer science, which is Boolean logic. Now, Boolean logic allows you to bind things together. So for example, if you press down the mouse and you press the spacebar, what happens? Compared to if you press the spacebar or you press the mouse down, what happens? And those words are very important to sort of work out how they're linked, and then more importantly, how to link that into your game that you might be building. So here's basically the three different terms that you need to know is and, or not. And this is basically where we're going to cover Boolean logic. Now, Boolean is the data type that we've talked about before, which is just true or false. And all these expressions evaluate down to being true or false. So if you've got a bit of a math brain, this lesson's for you because it covers some pretty interesting links to that. So understanding the basic principles of Boolean logic, which was introduced by George Boole, is the first learning intention. Then we're going to explore and, or, and not operators using some practical coding challenges, and then apply Boolean logic to some real world scenarios, understand its relevance inside of computing. And then finally, we'll see how the Venn diagrams link Boolean logic. So Venn diagrams are those circles inside of squares that sort of help you understand the links. So George Boole, way back in the day, even before computers really existed, was a mathematician who basically invented the whole of logic and math. So he found that logic and math, there was an equivalence and an overlap between the two. And he found that all logic functions are determined using these three primary Boolean operators, which is and, or, and not. So what he found was and narrows your options. So if I want, I don't know, a burger and fries, I'm only happy if I get both of those things. So it narrows it down. If I say or though, it broadens the options. So it widens the choices. So if I say I want a burger or fries, I'm happy if I get the burger. I'm also happy if I get the fries, but I'm also happy if I get both. And then last, you've got not, which is used to exclude options. So that's where you flip the script and change what you're sort of looking at. So how do the two choices different work? Well, basically, if you have an event A, you can either be true or false, right? And if we think from a computer science perspective, that's either 0 or 1. Then if we branch that out using a probability tree, you can then go false and true again. And then for event B, you can get false, then true. This is mapping out every single possible choice that can happen if you have two events. So the mouse button's pressed down or the space bar is pressed, and then you can sort of branch out and see what happens. So if we put George Boole on this and follow along, if we go this way with not A and not B, you'll see that's false, false. If he follows the next branch, it's the same as not A and B is true. So that's false, then true. Then if he follows the third branch, he's getting A and not B. So that's true, false. And then for the last branch, it's where everything's true. So it's where A is true and B is true. Now, hopefully what you've done is you've picked up my language there where I've talked about each branch and saying A and B. So if we had event A and event B, all the different possible combinations is you can have false, then false. You can then have false for event A and then then true for event B, true, then false, and then true, then true. Now, if you look really carefully at that, you should be able to see a binary math pattern. 0, 0, 0, 1, 1, 0, 1, 1. That pattern actually repeats all the way through. So if you want to do 3 events, same thing happens. You have exactly the same thing, except instead of 4 options, you will now have 8. If you did 4 different events, you then have 16 choices to choose from. But it follows that binary math counting, which is what we've done before, just to give that link. So your turn. We're going to try and do the AND challenge first. So what's going to happen is you're going to change the values of A and B in the following code and try all the 4 combinations to see what the value of X becomes. So we're going to set A is equal to false, B is equal to false initially, and then try all 4 different combinations. So we're going to try X is equal to A and B, and then print out X to see what happens. So just pause the video and have a go. Awesome. So what you should have found if we open up idle, let's build this little bit of code. So I'm actually going to build this as a script because I want to repeat it a couple of times. So I'm going to go A is equal to false, B is equal to false, lowercase b, and then X is equal to A and B. Then I'm going to print out X. Let's see what happens. So this is our Bool version. So if I run that, you should get false because they're both false. I'm going to then change B to true. Save that and run it. And then you also get false. Then I'm going to swap this guy. So the first event to be true and then B to be false. Save that and run it. And it's also false. And the last one, we'll make them both true and then run it. True. So what you should see in the truth table here is when you use the AND, it is only true if both the inputs are true. So basically, if we have event A, we have false, 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 true, true, false, and then true, true. A and B, when we did it, was false. Not A and B was true, false, and then A and not B was false. And the only time this thing turns on is if they're both on, which is true. So if you've done any physics before with circuits, this is the same as having something in series. So a light switch won't turn on unless the flow occurs where both things are on, and then it turns it on. So then there's that connection to join it. So now we're going to try and do OR. So we're going to see the 4 different combinations of what happens with OR. So we're going to slightly change this code around and then just see what all the outputs are. So have a play, try all 4 combinations again and see what happens. Awesome. So here is the code. So we're going to swap this basically to OR. We're going to go false and false. Actually, I'm going to cheat here. Let's be lazy. So we've got the 4 different combinations. So I'm going to go false, then true, copy, paste, paste, paste. See what happens. Cool. Awesome. So what you should see is if you had false then false, that's the only time that it will not work. And then all the others will turn on basically as long as there's one true in the inputs. So if you think of a keyboard, if you press spacebar or the mouse to make the character jump, if you just press the spacebar, the character would still jump. If you just press the mouse, the character would still jump. But if you press both, it also makes a jump. So a common misconception when people hear the word OR in computer science, they think it's one or the other. Now that does exist. We actually call that exclusive OR, which we'll do probably a bit later. But the idea behind OR basically is a broadening option. So it gives you more choices, which is pretty cool. So also note when you write true and false in Python, make sure you always capitalize it. So if we had false, 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 true, true, false, and then true, true, false, false is the unique case. Basically every other time in the Boolean operation with OR, it will always be true. So if both of them are off, it becomes false. Now, if you've done any physics, this is the same as putting something in parallel. So as long as there's one way of connecting through, the circuit will be connected, and then the electricity or the current will flow. So false then true became true, true then false became true, and then true then true became true. The next one is not, so that's the last one. So you should know and or not. Those are the 3 that we're going to cover today. So basically what happens with not is it just flips it. So trues become falses, falses become true. So we got this bit of code here, A is equal to false, X is equal to not A, and then we're going to print out X. So we're going to change this around, go A is equal to false, X equals not A, and then we're going to print X. And then, because I'm lazy, copy paste. And then we're going to swap this guy up here to true. Save that. Give it a run. And cool. Exactly what should have happened. So they basically invert or flip the values. So falses become trues, trues become false. So in the truth table, I've used the exclamation mark here just so that you get that link again, because we saw that when we did not equals. Falses become trues, trues then become falses. And there's a whole heap of different ways of writing notation when we do Boolean logic, by the way. I'm going to try and keep it as basic as possible to start. If you are interested, there are some other videos I'm going to try and put together for that. So what is a Venn diagram? You should remember this from math. It's basically the sample space of all the possible options inside of a rectangle. And then what happens is you draw circles to cut off these different areas. So if we have this little diagram here of green and spotty, the one that is green is on the left, all the things that are spotty is on the right. And then you should notice there's this overlap where things are green and spotty. Anything that isn't green and spotty is outside of these circles. So that's basically how they work. Also note Venn diagrams, not always to scale, but they give you a good picture reference of how it all sort of looks. So as a math nerd, I always like referring back to a deck of cards. So if you had a deck of cards with every single choice, you should remember that there's 52 different cards to choose from. And then in every suit, there's 13 cards with 4 different suits. And then you have the numbers from 2 to 10. And then the sort of more powerful cards, the Jack, Queen, King, and the Ace. And then depending on the game, sometimes an Ace is represented as 1, or it's represented as the most powerful card in the decks. So how do you create a Venn diagram? If we wanted to look at all the aces and spades. So we're going to make one circle showing all the aces, and then one circle showing all the spades. So here's all the cards that we have available. If you think of the Venn diagram, this is what it would look like. So you have the yellow and the green area that represent the aces, and then the blue and the green area that represents all the spades. So you should see the green area is the overlap, and then that red area outside is anything that isn't part of it. Now, what you should notice inside these Venn diagrams, which is the link, is that there's 4 separate areas. So there's an and part. There's a part where there's only the ace and not the spade. There's the part where there's the spade but not the ace. And then there's the red area, which is the same as the not ace or nor the spade. So there's only one card that sort of fits that bill, where it's the ace of spades, right? So there's 1 out of 52 for that part. Then there's 3 cards that fits into that yellow area. So they're the things that are just aces, but here's the key word, not spade and not spades. That yellow area is the same as ace and not spade. The blue area then is everything that's a spade, but not an ace, which is what that represents. And then the last bit is everything else. So that just jams around, which is not an ace and not a spade. And if you think of a tree diagram, which hopefully you've saw what I did at the beginning, it's exactly the same thing, but it's just been represented in a slightly different way. So if we think of bugs, like we saw before, we've got a whole heap of different bugs here to choose from, and we're going to try and put them into a Venn diagram. So we had everything that's green, then everything that's spotty. There is only one bug that matches the and part, where it's green and spotty, which is this guy in the middle here. We then have 3 options that are just green and not spotty, which is this guy here, and then this guy here, and then this one over here. So now we have every single thing that is green on this Venn diagram. If I then want to think about things that are just spotty, there are 2 options, right? So where they're spotty and not green is the red bug, and then also that purple one down the end. And lastly, we want to see if there's any bugs that are not green and not spotty, which is the orange one, the little racing stripe dude, and then also the teal guy at the end. So that's a pretty easy way of seeing how the different pieces go into the place of the Venn diagram. And you should be able to see where the and area is and where the or area is. So and, hopefully you've picked up, is that middle part, which we actually call the Vespa Pisces, which is that inner little part with the overlap. And then the or would be both the circles. So all the things that are inside the circles match green or spotty. Then anything that's not green or spotty is everything that's outside, which is kind of cool. So then you start picking up on how these words work and how they sort of interconnect. So the and operator, hopefully you've picked up now that it means both, all, or the intersections. So these all mean the same thing. It will only return results when both things are true. So when both conditions are true, it turns the thing on. So if you had everything that's red, then everything that's big matches the Vespa Pisces in the middle there. That's where the true, when it's true, if it's both red and big. And something that's very red and big that we all know and love is Santa, right? So that's a practical example of something that matches the and part. If we think of something that's green and spotty, well, hopefully picked up from the things that we talked about before, is just this guy here. There's only one, which is this guy. So if we were thinking about the colors here, so we had green, blue, purple, and red, the only part that's A and B is that purple area in the middle there. So that's where the overlap occurs. So your challenge, try and build this. So we're going to build a game called Less Than 5. So you're going to make a random number assign the values number 1, number 2, and go a number from 1 to 10. You're then going to print out the values for both number 1 and number 2. And then if both numbers 1 and 2 are less than or equal to 5, you print out you win, else you print out you lose. Now this is going to use a new function, so that we're going to import another library like what we did with Turtle, but this time it's going to be the random library. So we're going to import random, and then we're going to set the values for the two different numbers that we want to check. So we're going to go number 1 is equal to random.randint, which makes a random integer from 1 to 10, and then number 2 with the same function. So that creates all the code that you need to know what the names of the functions are. So hopefully pause the video now, see if you can actually build this code. Awesome. So what you should have found when you insert the code after this is, first of all, you want to probably print out what those numbers are so you can get your head around what they look like. And then it's a simple if statement. So if num1 is less than or equal to 5 and num2 is less than or equal to 5, print out you win, else print out you lose. It's a pretty simple game. So just to show you how that works, let's build the actual script. So we'll jump into idle, we'll go new. So we're gonna import random. Then we're gonna go num1 equals random. So from the random library, randint brackets 1, 10. Then num2 equals random.randint 1, 10. So that makes the two random numbers. Then we're going to check the numbers. So we're going to go print num1, and that's what num1 is. And then we're going to just go the same, print num2 is num2. Then we're going to check to see if the numbers are less than or equal to 5, which is what the rule was. So if num1 is less than 5 and num2 is less than 5, and I like putting spaces between my less than and greater than symbols just so it makes it a bit easy for me to read. That's just a personal preference. You can do what you need to do. Then you go print, you win. Else, so then the other option is obviously you lose. And then there's a quick little game that we've built that should, we'll call this the end game, and now we run it. So num1 was 8, num2 was 4, so therefore you lost. We'll run it a couple of times. So you lost. Let's keep going until I win. There we go. Awesome. So because they were both equal, I finally won because num1 was 1. So if both num1 and num2 are less than or equal to 5, you win. And then that was the condition here. So they both was less than or equal to 5. Therefore, I won. Fantastic. So hopefully that's worked there for you as well. The OR operator is next. So hopefully we picked up what that means. It means either, any, or the union. So this will return true when either conditions are true. So OR includes and, if you think about it. So that Vespa Pisces in the middle gets included in the conditions when we do OR inside of computer science. So if you say everything that's red or big would be everything that includes Santa, everything that's red, and then everything that's big. And for the Star Wars nerds out there, I will include Jabba the Hutt. Right. So if we say anything that's green or spotty, first of all, I always like saying the and one because that is green or spotty. It matches both conditions. You then have everything that is green thrown into the mix. And then at the end, when we do green or spotty, we also include all the spotty bugs. Everything else is not green or spotty. See how I'm starting to use some of the language here. So this is where everything that's inside the circles, they're like a little fortress. And then they match what has happened inside of all. So if we had green, blue, purple, and red, and we're trying to think about what is A or B, we should notice that the green is the only thing that should fade away. So everything that's A or B is the blue area, the purple area, and the red area. So we're going to change the OR game a little bit different now. So now what we're going to do is make the random number generator work again. But this time we're going to use OR, and we're going to check to see if the number 1 or number 2 are greater than 5, and print out you win. So pause the video, change your code around, and see what happens. Awesome. So what you should find, same thing again, you've printed out the numbers, and then number 1 is greater than 5, or number 2 is greater than 5, print you win, else print you lose. So let's just have a look at the code there. I'm going to change this around. So instead of the less than symbol, it should be the greater symbol. This should now be OR. And then this should be greater than. So now if we run this a couple of times, I lost straight away. I wasn't hoping for that, but that's okay. Run it again. Lost again. I was hoping statistically you'd see that you win more times now. So because you've got OR, you should have more chances of winning each time, because what happens is you're widening your choices compared to the AND, which is pretty cool. Good. So statistically it's picked up, and now I'm winning again. Awesome. So bit of a joke for you, for those that have seen Sasha Bowen. I always forget his last name. Sasha. He's really good. He does Borat. So here's a not joke that he's done.
A not joke is when we're trying to make fun of something, and what we do is we make a statement that we pretend is true, but at the end we say not, which means it's not true.
So teach me how to make one.
All right, what color is your suit?
This suit is gray.
Gray, I would call it blue, okay?
It's gray.
All right, it's blue-gray, but it's certainly not black, right? All right, let's say it's gray.
And he does it so well.
Gray.
Okay, so a not joke was, I would say, that suit is black. Not.
This suit is not black.
No, not has to be the end.
Okay.
Okay.
This suit is black, not.
This suit is black. Pause. You know what a pause is?
Yes.
This suit is black. Not.
This suit is black. Pause.
So you should see that he's trying to say not.
No, you don't say pause.
But he's doing
this
it at the wrong
suit is black. That's a pause. Not.
This suit is black.
Okay. I'm not
Not.
quite.
Awesome. So what you should see now, if we keep going from here, is the not operator. So the way the not operator works is it's neither, no, or a negation. And it returns values that are opposite of the condition. So if you start here with red, then big, anything that's not big is everything that's outside of that circle. So again, think of a fortress that's been protected by not, means everything that's outside is not big. So that includes everything that's not red and not big. Then also, it also includes everything that's red and not big. If you think about those branches in the tree diagram we did at the start. So everything that's red, Fanta, and I had Taylor Swift as well there. So those are the things that don't match that. So everything that's not green in this case is everything that's outside the circle of green. So it would be the red spotty guy, the purple spotty guy, then also the orange star dude, the lightning bug, and then also the teal guy at the end. So if we had this color here with green, blue, purple, and red, everything that's not A would be the green area and then the red area. So there's an old saying to help to get your head around what not means. It basically, it's been around for ages. You can't have your cake and eat it too. So that's why you can't have the two events happening at the same time. So by using not, it allows you to exclude options and flip the script, which is really important if you're thinking about your game. So for example, if you're not pressing spacebar, you might have something not happening. So here's a little challenge. Pause the video once you've had a read. So basically make a random number generated from 1 to 10, print out the numbers for both 1. If num1 is not equal to 5, print out you win, else print out you lose. So have a go there. Use the random library generation that we did before, and then just change the code slightly. Cool, so what you should find here is we're gonna change this code a little. So this line here, all we're going to do is then change not num1 equal to 5. And then snaky bite. So if number 5, if the number generated is not number 5, it's not going to work. So let's just delete those, save it, and then run the module. Cool. So I won because it was not equal to 5. I'm going to keep winning this. See how long this takes me until I get my 5. Nope. Yes, finally I lost. So that's the way this code works. So basically, you've gone not of num1 is equal to 5, print out you win, else print out you lose. That's pretty much how it works. Awesome, so that should hopefully give you some ideas. We're gonna do a quick little challenge here just to test your understanding of Venn diagrams. So I've got everything that's a turtle, everything that's a ninja, and everything that's not a ninja. I've got 4 different things there. So I've got a turtle on the left, I've got a ninja turtle in the middle, I've got a hardcore ninja on the right, and then a unicorn that lives outside of it. So if we have these 4 different things, just pause the video and think about what color for each would be left over, and then we'll go from there. Awesome. So for the first one, not a ninja, would be everything that's outside of the ninja circle. So that would be the blue area with the turtle and then the unicorn as well. If we then exclusively wanted a ninja or a turtle, so exclusively or is a little bit different. Exclusively means that you only have the blue area or the red area. So exclusively a ninja or a turtle means that you can't have both in the middle, which is tying into a concept called XOR, which we haven't quite seen yet. Neither a ninja or a turtle would be this area here. So it would be the green area because it's not a ninja or a turtle. And then the last one, a ninja and a turtle, or neither a ninja or nor, and that should say a turtle, which is basically that area there. So we can we can merge these words together to match what we want to sort of do, which is kind of cool. So the other one that I've done before is you can have actually 3 events. And remember how we talked about how many options happen each time. So if you had a deck of cards, we've built a Venn diagram here that has the conditions that are even, the diamonds, and then the things that are less than 6. So before, when we had 2 options, there was 4 quadrants, 4 sections inside of the Venn diagram. This time, because there are 3 events, there's now 8 sections if you count them. So there's 1, 2, 3, 4, 5, 6, 7, 8, which is pretty cool. So if we think about that, everything that's even a diamond and less than 6 goes in the middle. So there's only 2 things. There's the 2 diamonds and the 4 diamonds that matches that condition. If you then went even and a diamond, there's these guys here. If you then went less than 6 and even, is these guys here. So it's just these conditions. Then if you went less than a diamond than less than 6, you had the 3 of diamonds and the 5 of diamonds. Then if you had just diamonds, only diamonds, so diamonds and not even and not less than 6 is everything else. Then if you had everything that's just evens, would go on the side there. Everything that's less than 6 goes down the bottom here. And then everything else around the edge. So hopefully that shows you how a 3 event thing sort of looks like, which can happen. So La Piazza is my favorite pizza ever. It's basically ham, mushroom, and pineapple. It is delicious. There's a place in Broadbeach called Mario's. Hopefully they'll sponsor me. but they make the best pizzas on the planet, in my opinion. So La Piazza, the way that you make Hendo's favorite pizza is you do the Venn diagram below, and basically you put these ingredients together. So you have ham, mushroom, and pineapple. So to make La Piazza, have a think about these different things, and we'll come back and talk about what areas they might be. Awesome. So to make La Piazza, there is only one part of all those colors, which is the overlap in the very, very middle, which is that brown section. So to make La Piazza, you need ham, mushrooms, and pineapple. I'm drooling already trying to think about this pizza. If you made a pizza with only one of the toppings, sorry, there's a little bit of editing that I need to fix there. Basically, it would be all the primary colors. So they're just the things that have only ham, only mushrooms, and only pineapple. If you made a pizza with at least 2 toppings, would make the little cool symbol in the middle there. So that's where there's 2 toppings or 3 toppings. So that includes La Piazza. So if you made a pizza with just mushroom and ham, or mushroom and pineapple, or ham and pineapple, that matches that. And then if you want to make a pizza that only uses that uses ham and pineapple, would be this little Vespa Pisces at the end here. So it includes La Piazza, but also the just a ham and pineapple. So Boolean operating summary that we should pick up here is if we use the word and, means both conditions are met, which makes that Vespa Pisces in the center. If you're looking at or, means either conditions are met, which includes everything. And then if you do not, means a condition is never met, which means it's everything that's outside of the fortress. So there's a whole heap of coding bad examples here that I'm quickly going to try and punch out. They're really, really handy if you want to sort of improve your skill set here. So coding bat, we're going to have a go at this guy. So given 2 integers a and b, return their sum. However, if the sum is in the range of 10 to 19 inclusive, they're forbidden, so just return 20. So this is where we've got something called a range. So we're going to sum these together first. So I'm going to go, the sum is equal to a plus b. So that stops me from doing that over and over and over. So we're going to go if return their sum. However, if the sum is in the range of that, we're just going to return inclusive are forbidden. So that in that case, just return 20. So if, let's think about this. If the sum is less than or equal to 19, because we're including that, and the sum is greater than equal to 10. So if it's less than or 19 and it's greater than or equal to 10, we just return 20. Otherwise, let's just return the sum. So that's a special condition that's occurred, which is why I like using a post box here. And then hopefully that works. Awesome. Cool. Different way. Again, I did this at PowerPoint a while ago. So if you've got x is equal to a plus b, basically if x is greater or equal to 10 and x is less than or equal to 19, you return 20, else you return 9x. In this case, personally, I prefer the post box option because it's kind of a flag condition. It's kind of making it a bit of the exception. So then it's a bit more clear what has to happen. So this is a squirrel party one. This is pretty cool. The squirrels in Palo Alto spend most of the day playing. In particular, if your temperature is between 60 and 90 inclusive. Unless it is summer, then the upper limit is 100 instead of 90. Given the in temperature and the Boolean is summer, return true if the squirrels play and false otherwise. So you got 70 and false, which is true, and so on. So this one's a little bit more complicated. So the squirrels play most of the time. So squirrels in Palo Alto play if the temperature is between 60 and 90 inclusive, unless it is summer. So I'm going to do an if is summer and do a little bit different. So if it is summer, let's just do it as normal. So if it is summer, then we'll go if they're between 60 and 90 in this case. So if, actually, let's do this. This is another way that you can do it in Python. So a little bit different to other languages. So you can do less than or equal temp 90. And then less than or equal to 90. It's a little bit different. It's not quite and statements, but it's kind of cool just to see. And then we want that to return true. Else return false. Then else if it's between 60 less than or equal to temp less than or equal to 90, return true. Else return false. And that should have been 100 back up here. Didn't like it. Didn't they like? Line 5. 1, 2, 3. Snaky bite. And see how I did the syntax there? So I looked for line 5, 1, 2, 3, 4, 5, said where the error is, and then I looked at it and was like, oh, I forgot my snaky bite at the end. That's pretty cool. So there's some other things that we can do here. I've done a bad thing. Well, not a bad thing, but I've basically said, if this is true, return true, else return false. What we should have picked up is that you can just go return that. Which then is a lot easier. And then down here, just going to return this value. This is what we call refracting, which then makes the code a little bit more simpler and then easier for people to read. Cool. So that's the way that you could do it with an and statement, sorry, as well. So you could go, if it is summer and the temperature is greater than 60 and the temperature is less than 100, return true. Else if it's not summer and the temperature is greater than 60 and the temperature is less than 90, return true. Else return false. You could also make a super statement at the top here and do is summer and temperatures greater than 60 and temperatures less than 100, or this statement through here. But then it gets a little bit more confusing, which is why I actually like this way, because it is a bit easier for someone to read. So if it is summer, check this, else check that. Cool. So we're going to have a go at this. Squirrels get together, have a cigar party. Squirrel party is successful when the number of cigars is between 40 and 60 inclusive, unless it is the weekend, in which case there is no upper bound to the number of cigars. Return true if there is a party basically happening. So if there was 30 cigars, so it's not between 40 and 60, and then it's not the weekend, so nothing's going to change here. So since Coding Bat likes the cigar party, but we'll go with it. So if, let's think about this. So if it's the weekend and let's check the cigars is greater than equal to 40 because there is no limit. Return true. I'm going to use an elif here. Elif it's not is weekend and cigars greater than equal to 40 and cigars less than equal to 60. Snaky bite. Return true, and then else return false at the end. Let's see how that goes. Oh, still remember how to code. Fantastic. So this is what it did. Check to see if it's the weekend and cigars. If it's not the weekend, came true, else return false at the end. Let's go through this one here. So we're going to go through you and your data trying to get a table at a restaurant. The parameter is you. It's the stylishness close, and in the range from 0 to 10. And date is the stylishness of your dates. Close, the result, getting the table is encoded as an int. From 0 is equal to no, 1 is a maybe, 2 is a yes. If not, either of you is very stylish, 8 or more, then the result is 2, with the exception that if either of you has a style of 2 or less, then the result is 0. Otherwise, the result is 1. So let's unpackage that. So what you need to think here is the exception. So the exception is that if either of you has a style less than 2, then the result is 0. So if you are less than 2, less than or equal to, or your date is less than or equal to 2, snaky bite, return 0. Elif, let's think what would be next. So you is parameter blah blah blah, stylish is the date, the result's getting encoded. If either of you is very stylish, 8 or more, then the result is 2, with the exception being that if either of you is 2 or less, then the result is straight away just 2. Yeah, cool. So Elif, we want to check if you are greater than or equal to 8, or your date is greater or equal to 8. Notice how we did the exception first. And then else, at the end, return a 1. Cool. So what happens here is this is the exception. So this is very important that we sort of pick up on this word. So with the exception, either of you has a style of 2 or less, that has to be triggered first. So that overrides if you are very stylish of 8 or more. That's the exception, so you need to make sure that you include that. Cool. So what we should find now is that's what happened here. Cool. So you're driving a little bit too fast. The police officer stopped you, writes a code to compute the result encoding value. So you get no ticket, a small ticket, a big ticket. If the speed is 60 or less, the result is 0. If the speed is between 61 and 80 inclusive, the result is 1. If the speed is 81 or more, the result is a 2. Unless it's your birthday, on that day, the speed can be 5 higher in all cases. So what I'm going to do is do a little bit of a hack here. I'm going to increase the value of speed if it is your birthday. So this is where understanding the 3 different types of if statements helps a heap. So if it is your birthday, and notice that I don't have to say is birthday equal to true, because it just is true or false. I'm then going to add speed plus equal to 5. Then that handles all the different things that happen with the speeding. So now I'm going to return the different results. So if the speed was if the speed is 60 or less, so it's less than or equal to 60, snaky bite, I return it a 0. Elif, the speed is between 61 inclusive, I'm going to use my little notation here. So 61 less than or equal to speed less than or equal to 80. Snaky bite, you get a 1. And then else, return a 2. Run that. It's not quite working. What's wrong with my code? Sorry. Need to take off 5. That's why. So the speed, you can go 5 higher in the case. So I'm going to take away 5. See if that works. Yeah. So that the speed basically can be subtracted. So it's if you were traveling at 60, it's the equivalent of as if you're doing 55. Cool. Let's see how that goes. Yep. So same thing that I've worked out before. Pretty straightforward. This one here, a little bit more challenging. Given a day of the week, encoded as 0 is Sunday, Monday, Tuesday, and Saturday, and a Boolean indicating we're on vacation, return a string in the format of 7, a clock indicating when the alarm clock should ring. Weekdays and the alarm should be 7, and on weekends it should be 10. Unless we're on vacation, then on weekdays it should be 10, and on weekday ends it should be off. So let's jump on into this one. So this one's a little bit harder. So you got this Boolean condition checking to see if it's Sunday or Saturday, and then also if it's on a vacation. So let's think this through. So if we're on vacation, so if vacation is true, let's start with there. Return a string at 7 indicating the alarm clock should ring. Weekends it should be 7, and weekdays. So hang on. If it's on vacation, the weekdays it should be 10 o'clock, and then weekends it should just say off. So if let's say the day, here's another way that you can do it, is in this list. So 1, 2, 3, 4, or 5. So if the day is within that, we're going to return 10 o'clock. So that's another way that you can use the in command, which is kind of cool. I don't think I've shown that before. Else we're going to return off. Else, if the day is in 1, 2, 3, 4, 5, return 7 o'clock. Else, return 10 o'clock. Have a run of that, see what happens. Awesome. That's another way that you could have done it. So if vacation and if the day is equal to 0 or the day is equal to 6, return off. Else return 10 o'clock. Else if day is equal to 0 or day is equal to 6, return 10. Else return 7. How we go with this guy? So the number 6 is truly a great number. Given to int values a and b, return true if either one is 6 or if the sum or difference is 6. Note if the absolute value of the number. So here we go. We'll go sum. Equals a plus b. And we'll go diff. Let's see if this works. Abs a minus b. Then we want to go if sum equals 6 or diff equals 6 or a equals 6 or b equals 6. True. Oh, I'm just going into all patterns. Let's just return that. Cool. So what happens here is we add the two values together first. So we're going to go a plus b. And then we're going to go through and do the difference. So abs basically means the absolute value. So it's the distance between a minus b. If that equals 6, it just basically gets rid of the negative symbol. Then it checks to see if a is equal to 6 or if b is equal to 6, which is pretty straightforward. Must have got annoyed with the abs function. So I went through and just booleaned it and did all the different combinations. Also noticed that I didn't use the smart way where I just add one. Kept doing it. Given a number n, return true if n is in the range 1 to 10 inclusive, unless outside mode is true, in which case return true if the number is less than or equal to 1 or greater than or equal to 10. Okie dokie. So So let's think about this one. So given a number n, return true if n is in the range 1 to 10, inclusive, unless outside mode is true, in which case true if the number is less than or equal to 1 or greater than or equal to 10. So if it's in outside mode, let's do that first. So if it, in which case, unless outside mode is true, in which case true if the number is less than or equal to 10, 1 or greater than or equal to 10. So let's go just straight and just write it. The return n is less than or equal to 1 or n is greater than or equal to 10. Else, we want to check to see if it's inside that range. So let's, well, we don't even need to do it. It's just a condition. So we'll just literally go return, because it's the other option, outside mode, return true if n is inside the range 1 to 10. I'm going to be a little bit lazy here. Let's see if this works. I'm not sure if it will. Yeah, cool. So you can actually use the range function as well, which is like a for loop, what we've done before. What this does is it spits out all the numbers from 1 to 10. So what happens is it checks to see if n is inside that, and if it is, it's true, otherwise it's false. Which is kind of cool. The other way that you could have done it is gone like this. So if not outside mode and n is greater or equal to 1 and n is less than 10, return true, else return false. Else, if n is less than or equal to 1 or n is greater than 10, return true, else return false. But notice that this is redundant by writing it like this. Given a non-negative number num, return true if the num is within 2 multiples of 10. So a mod b is the remainder divided by a divided by b. So 7 mod 5 is 2, and so on. So we should be able to do the mod. So given a non-negative number num, return true if the number is within 2 of the multiple of 10. So let's think this through. This is a little bit trickier. Let's go. Are you? Is equal to num. Mod 10. So that's going to give us the number. Then we want to return true if the value is 2 within that. So it's either going to be 1 or 2, or also 9 and 8. So I'm going to cheat, well not cheat, but I'm going to go to the value that we're going to look for is in, and then I'm going to put just the values. So it's in either 8, 9, 0, 1, or 2. In those, it should return true. Cool. I really like using the in function. It's super handy. The other way that you could have done it here, so you had check is equal to num mod 2, and then check to see if num is greater than or equal to 0 and check is less than or equal to 2, or check is greater than or equal to an 8 and check is less than or equal to 9, return true. Yeah, could do that, but I like my way better. So some conclusion questions. Think about how Boolean logic can be applied to make a simple game. You will need to know this later down the track. Can you think of everyday situations where Boolean is being used but you don't really realize it? And how would you explain the importance of Boolean logic in a computer program to someone that's never programmed before? Now there is a Kahoot online that you can play. Super useful to sort of practice the skills that we've covered today. There is a lot. This is probably one of the more intense lessons, but once you've done this, the skill set that you get by using and or is irreplaceable. So that's it from me. Hopefully you've picked up how Boolean logic works and you understand the difference between and, or, and not, where and narrows your options or broadens your options, and then not means that you're not going to do it. That's it for me. Please like and subscribe down below, as it does help with the YouTube algorithm. I really would appreciate it. And yeah, see you next time on Steam with Steve. Adios.